So in this question, we have been given a quadratic equation which is x square plus ax minus 4 is equal to 0. And we have to find out the range of a for which this given quadratic equation has its smaller root in the interval minus 1, 2. All right. So this is the quadratic equation given to us in the question. It's also given that the smaller root lies in the interval minus 1, 2. All right. Now let me first consider that one root surely lies in the interval minus 1, 2. So f of minus 1, if it is greater than 0, f of 2 would be less than 0 because they would be of opposite sign. All right. If f of minus 1 is less than 0, then f of 2 would be greater than 0. These are the two possible cases. But which of these two cases actually satisfies the condition smaller root belongs to the interval minus 1, 2? For that, we will calculate f of 0, where f of x is defined as x square plus ax minus 4. All right. So f of 0 is equal to minus 4. Now, as f of 0 is equal to minus 4, it is negative. That means now for this condition to hold true, smaller root belonging to the interval minus 1, 2, we have to consider the first case where f of minus 1 is greater than 0 and f of 2 is less than 0. Well, in the other case, we will have the bigger root lying in the interval minus 1, 2. So if I draw the graph for f of x, this is how it will look. So the first condition that we got is f of minus 1 is greater than 0, and the second condition that we got is f of 2 less than 0. So if we define f of x as x square plus ax minus 4 and calculate f of minus 1, what we will get is 1 minus a minus 4, and this is greater than 0, or we can say that a is less than minus 3. All right. Let's calculate f of 2. It is equal to 4 plus 2a minus 4, and this should be less than 0, or we can say a is less than 0. Now if I take the intersection of these two intervals, what I will get is a belong to the interval minus infinity to minus 3, which is same as option A. So in this question, we have to find out the values of m such that exactly one root of the equation x square plus 2 times m minus 3 times x plus 9 equal to 0 lies between 1 and 3. All right. So this is the quadratic equation given to us in the question, and we have to find out the values of m for which exactly one root lies between 1 and 3. As you can see that the coefficient of x square is 1. All right. So if I define f of x as x square plus 2 times m minus 3 times x plus 9 and draw the graph for f of x, we will have opening upwards parabola. Exactly like this. From here, we can say that f of 1 is negative and f of 3 is positive. That means f of 1 and f of 3 are of opposite sign. So what we will get is f of 1 multiplied by f of 3 is less than 0. All right. So if we defined f of x as x square plus 2 times m minus 3 times x plus 9, then we can find out f of 1 as 1 plus 2 times m minus 3 plus 9, which simplifies to give us 1 plus 2m minus 6 plus 9, which is equal to 2m plus 4. Similarly, let's calculate f of 3. It is equal to 9 plus 6 times m minus 3 plus 9. If I simplify it, what I get is 9 plus 6m minus 18 plus 9, which is equal to 6m. And we know that f of 1 multiplied by f of 3 is less than 0, because it's given in the question that exactly one root lies between 1 and 3 for the equation f of x is equal to 0. So if I put the values of f of 1 and f of 3 in the expression, we get 6m multiplied by 2m plus 4, and this is less than 0. If I factor out 2, I get 12m multiplied by m plus 2 less than 0. We have two factors. That means we'll have two critical points. It's minus 2 and 0. Now if I put m is equal to 1 in the expression, I will get 12 multiplied by 3, which is positive. So we'll start the wavy curve with positive. About 0 it will become negative. About -2 it will become positive again. Now we have open intervals at -2 and 0. But we want that interval where the expression is less than 0. And that would be m belonging to the interval -2, 0, which is same as option A. So in this question, we have to find out the values of m for which both the roots of the equation given by x square minus 2mx plus m square minus 1 equal to 0 are greater than -2 but less than 4. All right. So this is the quadratic equation given to us in the question. If we assume it has two roots, alpha and beta, then it's given that both the roots, alpha and beta, are greater than -2 and less than 4. All right. Or we can say that both alpha and beta belong to the interval -2, 4. All right. If I define f of x as x square minus 2mx plus m square minus 1 and draw the graph keeping in mind that both the roots of the equation f of x is equal to 0 lies in the interval -2, 4, then the graph will look like this. Now from here we'll get the conditions. First condition is d greater than equal to 0. Second condition is f of -2 greater than 0. Third condition is f of 4 greater than 0. And the fourth condition is minus b by 2a. The x coordinate of the vertex is greater than -2 and less than 4. Alright, starting with the first condition, d greater than equal to 0. We know d is defined as b square minus 4ac. So if we put the values of a, b, c in the expression, we will get -2m whole square minus 4 times 1 times m square minus 1. And this is greater than equal to 0. On further expanding, we get 4m square minus 4m square plus 4 greater than equal to 0, or we can say 4 is greater than equal to 0. Now we know that 4 is always greater than 0. That means m belong to the set of real numbers. So all values of m are acceptable because 4 is always greater than 0. Alright. Now moving on to the second condition, which is f of -2 greater than 0. So f of -2 would be -2 whole square minus 2m multiplied by -2 plus m square minus 1, and this is greater than 0. On further expanding, what I get is m square. Actually, on further solving, I'll get m square plus 4m plus 3 greater than 0. Now we can factorize this by splitting the middle term. The factors that we will get is m plus 3 multiplied by m plus 1, and this is greater than 0. Two factors suggest two critical points, -3 and -1. Hollow circle at -1, hollow circle at -3. Now if I put m is equal to 0 in the expression, I will get 3, which is greater than 0. So we start with positive. The wavy curve will start with positive. About -1, it will go to negative. About -3, it will become positive again. Now we are looking for the interval for which the given expression is greater than 0. That means m belong to the interval -infinity to -3 union -1 to infinity. All right. Moving on to the third condition, f of 4 is greater than 0. So when we calculate f of 4, we get 4 square minus 2 times m times 4 plus m square minus 1, and this is greater than 0. Now if I further solve it, I get m square minus 8m plus 15 greater than 0. We can again factorize this by splitting the middle term. The factors that we will get is m minus 5 times m minus 3 is greater than 0. Alright, so the factors that we got are m minus 5 and m minus 3. Now we have two factors. Two factors suggest two critical points, 3 and 5. Now we have hollow circle at 5, hollow circle at 3. And if we put m is equal to 6 in the expression, we will get 3, which is greater than 0. Alright, so we'll start the wavy curve with positive. About 5, it will change to negative. About 3, it will change to positive again. Now we are looking for the interval in which the given expression m minus 5 times m minus 3 is greater than 0. And that would be m belonging to the interval minus infinity to 3 union 5 to infinity. All right. Now moving on to the fourth condition where minus b by 2a is greater than minus 2 and less than 4. Now if I put b as minus 2m and a as 1, I get minus of minus 2m divided by 2, and this is greater than minus 2 and less than 4, or we can say m is greater than minus 2 and less than 4. We get m belonging to the interval minus 2, 4. All right. So we have got 4 conditions. We solved for 4 conditions, and after solving for 4 conditions, we got 4 intervals for m. All right. All we have to do is take their intersection. So after taking intersection, we will get m belonging to the interval. We have minus 1, 3. All right. So when you take the intersection of these 4 intervals of m, you will get m belonging to the interval minus 1, 3, which is same as option A. So in this question, we have to find out the sum of values of k for which the equation log of k to the base 5 the whole square plus log of k to the base 5 minus 2 multiplied by x square minus of 2 raised to power 2k minus 34 times 2 raised to power k plus 64 times x plus k square plus 7k minus 60 is equal to 0 possess more than 2 roots. All right. If you closely observe the equation given to us in the question, you will see that it's a quadratic in x. All right. And we know that a quadratic equation will have at max 2 roots. But in the question, it's been given that this quadratic has more than 2 roots. That means this given quadratic is going to be an identity. And when a quadratic is an identity, the coefficient of the quadratic should be equal to 0 simultaneously. That means this should be equal to 0, this should be equal to 0, this should be equal to 0. And we have to find out that value of k for which 3 of them, the coefficients of a quadratic equation will become 0. So starting from the coefficient of x square, log of k to the base 5 the whole square plus log of k to the base 5 minus 2 is equal to 0. As you can see, we have a quadratic in log of k to the base 5. So if I put log of k to the base 5 as t, I get t square plus t minus 2 equal to 0. Now if I factorize this, I get t plus 2 multiplied by t minus 1 and it is equal to 0. So t can be equal to minus 2 or t can be equal to 1. Now when I resubstitute the value of t as log of k to the base 5, what I get is log of k to the base 5 is equal to minus 2 or log of k to the base 5 is equal to 1. Now if I take antilog and calculate k, I will get k is equal to 1 by 25 or k is equal to 5. Alright, so we have solved the first equation where the coefficient of x square is equal to 0. Now let's talk about the second equation where the coefficient of x is 0. So we have 2 raised to power 2k minus 34 times 2 raised to power k plus 64 equal to 0. So if I substitute 2 raised to power k as p, I get p square minus 34p plus 64 is equal to 0. If I split the middle term, I get p square minus 32p minus 2p plus 64 is equal to 0. So, what are the factors that we are going to get? P minus 32 multiplied by P minus 2 is equal to 0. So, we get P is equal to 32 or P is equal to 2. But we know P is equal to 2 raised to power k. So, if we resubstitute the value of P as 2 raised to power k, we get 2 raised to power k is equal to 32, which can be written as 2 raised to power 5. So, we get k is equal to 5. Similarly, if we put p is equal to 2 raised to power k in the equation p equal to 2, we get 2 raised to power k is equal to 2 or k is equal to 1. So we have got two values of k from here, 5 and 1. Now talking about the constant term. Now when the constant term is equal to 0, we get x square, we get k square plus 7k minus 60 is equal to 0. Now if I split the middle term, I get k square plus 12k minus 5k minus 60 is equal to 0. Alright. On further solving, we get k plus 12 multiplied by k minus 5 is equal to 0. So either k is equal to minus 12 or k is equal to 5. Now if you see, for k is equal to 5, we are getting the constant term equal to 0. We are getting the coefficient of x is equal to 0. And we are getting the coefficient of x square equal to 0. So k is equal to 5 is the value for which simultaneously three of them, the coefficients of the quadratic is becoming 0. That means we can say that option A is the correct answer to this question. Alright. So in this question, we have been given a quadratic equation, x square minus a plus 2 times x plus 7a by 4 is equal to 0. Alright. Now we have to find out the interval in which a lies if at least one root of the given quadratic equation is less than 0. Alright. So this is a quadratic equation given to us in the question. If we assume it has two roots, alpha and beta, then it's been given that at least one root of the given quadratic equation is less than 0. So there are three possible cases here. Case 1 where both the roots are negative. That means alpha is less than 0 and beta is less than 0. Case 2 is when one root is negative and the other root is positive. So alpha is less than 0 and beta is greater than 0. Case 3 is when one root is negative and the other root is equal to 0. These are the three possible cases for at least one root being negative for the given quadratic equation. Alright. So now if we assume f of x as x square minus a plus 2 times x plus 7a by 4, we will get the graph of f of x as opening upwards parabola. Alright. So starting with case 1 where both roots are negative. If both roots are negative, d is greater than equal to 0. Minus b by 2a is less than 0. F of 0 is greater than 0 because we have a graph opening upwards. Alright. Starting with d greater than equal to 0, we will get a plus 2 the whole square minus 4 times 1 times 7a by 4 is greater than equal to 0. If we simplify it further, we get a square plus 4a plus 4 minus 7a greater than equal to 0. Alright. Now what we will get here is a square minus 3a plus 4 greater than equal to 0. Now I have a quadratic in A. If I calculate d for this quadratic, I will get minus 3 square minus 4 times 1 times 4 which gives us 9 minus 16 equal to minus 7 and less than 0. As we have d less than 0 and coefficient of a square as 1, we get this term a square minus 3a plus 4 always greater than 0 because we will have opening upwards parabola which is lying above the x-axis. So we can say that a belongs to the set of real numbers. Alright. Moving to the second condition, minus b by 2a is less than 0. So when we put minus b by 2a less than 0, what we get is a plus 2 divided by 2 less than 0, which implies a is less than minus 2. Alright. Now the third condition is f of 0 greater than 0. So we have 7a by 4 greater than 0, which implies a is greater than 0. If we take intersection of these two with a belong to the set of real numbers, what we will get is a belong to phi, or I would say that a is equal to an empty set. We get no intersection for these three inequalities or for these three intervals of a. Moving on to case 2 where one root is positive, the other root is negative. So we have f of 0 less than 0. We have 7a by 4 less than 0, which implies a is less than 0. Or we can say a belong to the interval minus infinity to 0. Now moving on to the third case where one root is 0 and the other root is negative. If one root is 0, f of 0 is 0, which implies a is equal to 0. And the other root is negative, that means minus b by 2a is less than 0. Alright, so we have minus of minus a plus 2 divided by 2, and this is less than 0. So what we have is a is less than minus 2. I have a less than minus 2 and a equal to 0. Now within case we have to take intersection. When we take their intersection, again we get an empty set. Alright, for case 1 we got an empty set. For case 2 we got a belonging to the interval minus infinity to 0. And for case 3 we get an empty set again. Now for cases, alright, for these three cases, we have to take the union. We have to take the union of the intervals of A that we get in individual cases. Alright, so what we get is A belong to the interval minus infinity to 0. Whatever we got for case 1, union whatever we got for case 2, union whatever we got for case 3. And when we took the union of these cases, what we got is A belong to the interval minus infinity to 0, which is same as option D here.